Solar energy is the future. Not only is it renewable, but it's also seemingly infinite, clean, and accessible. Right now, there are 1.2 billion people living with little or no access to electricity. That means that there are 1.2 billion people living in energy poverty. That's insane. So, if solar power has the potential to fix this, then why hasn't it yet? The thing is, there's a not so small problem. When solar energy is transferred through the atmosphere, 60% of it is lost. That leaves 40% of it. However, 25% of that remaining solar energy is lost in conversion from solar to chemical. That's unacceptable. I've been thinking into how we can fix this, because if we can revolutionize energy, especially clean energy, then we can revolutionize the world. For this, I propose using silicon nanowires. Currently, modern solar cells have an efficiency limit of 33.7%, according to the Shockley-Queisser limit. So, how do we get around the Shockley-Queisser limit? Well, the thing is, that isn't necessarily concrete. In fact, if we change the materials that the semiconductor is made with, we can increase the PCE, or power conversion efficiency. This ratio is optimized when the diffusion length of the wire is smaller than its thickness. And silicon does this very well. A higher aspect ratio, which is basically the surface to volume ratio, and smaller dimensions of nanowires can actually lead to some interesting solar cell applications. Current single junction solar cells have a limit of 33.7% efficiency, according to the Shockley-Queisser limit. That's unfortunate, right? Especially if we want them to take over. This is where silicon nanowires come in. Nanowires are basically wires that are just 1 nanometer thick in diameter. For context, a human hair is 50,000 nanometers thick, so these things are extremely small. Silicon nanowires are semiconductor nanowires. They're made from taking this silicon precursor and either etching a solid through it to make it a silicon nanowire, or by using a chemical vapor to catalyze its growth. Nanowire solar cells are effective in the sense that they allow for a thick absorbing layer to completely absorb the solar spectrum, while still allowing for a small spacing between two active compounds, whether this be the p-np junction or something else, so that short diffusions are still made present. In order to build these silicon nanowire-based solar cells, we first need to take an N-type zinc oxide nanowire and coat it in a layer of P-type copper oxide nanoparticles. The thing is, this solar cell won't actually work until we add a blocking layer of titanium oxide. Silicon nanowires are insane. Not only do they increase the efficiency and pass the Shockley-Queisser limit, but they also drive down the cost. I mean, who wouldn't want to use these? In the beginning of this video, I mentioned that there were 1.2 billion people living in energy poverty. Imagine the ways that their lives would improve if they had access to electricity. The first step in revolutionizing energy is actually obtaining it, and that's why we need to use silicon nanowires. It is from there that we will be able to improve the lives of so many people, literally impact billions, and I think that's absolutely crazy, and something that needs to be done.